So to solve the equation ax squared plus bx plus c equal to 0, one method that we have been using, there we go, one method is to factor ax squared plus bx plus c when possible. Yeah. For example, we did this one last time. Yeah, we'll do this one. Might just go on paper. So for example, we solved x squared minus 5x minus 6 equal to 0 previously by just factoring it. We multiplied or wrote it as x, and we know we want to multiply to negative 6 and add up to negative 5. So I want a minus 6 and a plus 1. And I'll remind you, right? The numbers that we get here are actually the opposites of the answers that we're actually looking for, right? I put a negative 6 here and a positive 1 here because we multiply to negative 6 and we add up to negative 5. But then our actual solutions are x minus 6 equal to 0, which gives me x equal to positive 6, and x plus 1 equal to 0, which gives me x equal to negative 1. And that is certainly a valid way of solving this equation. And for this particular equation, it's probably the actual way I would choose to do it, right? This is, for me, for this equation, this is the best way to solve it. But there is another way. Another way to solve the equation ax squared plus bx plus c equal to 0 is just to use the quadratic equation, or the quadratic formula. And in that case, we just write out the formula. So the solution is, or solutions are, x equal to, and it is important. So when you're writing the solution, it is always whatever your variable in your equation is. So we're solving this for x, we're going to get x equal to, and I imagine this is a formula most of you are probably familiar with, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. That's the quadratic formula. It's probably worth memorizing, even though you could totally look it up anytime. It's still something that's good to just have in your head to not have to look up if you're trying to use it. So for the problem we just did, it's also nice to see that whether you use the quadratic formula or whether you factor, you're still going to get the same answers. So if we take the previous equation, x squared minus 5x minus 6 equal to 0. You don't have to write down what a, b, and c are, but if you think you might be prone to missing a sign, I would recommend writing down what a, b, and c are. So for this quadratic equation, a is equal to 1, b is equal to negative 5, and c is equal to negative 6. It's really important that we carry the negatives if they're there. So then our solution, I should say solutions, are going to be x equal to plus or minus, sorry, I already blew it. Forgetting part, before the plus or minus, there's a negative b. So it's going to be negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 6. All over 2 times 1. And then we definitely should simplify these quadratic solutions as much as possible. So if you're using the quadratic formula, one thing that usually is going to be true versus factoring, and I should say, this is why I usually prefer to factor if I can, because if you factor, usually the answers just come out nice and neat, right? They're already there. Whereas if you use the quadratic equation, there is a little bit more simplifying we have to do. So this is going to end up equaling, hopefully I have enough room here. Let's see, negative 5 is 5, plus or minus the square root of negative 5 squared is 25. Be careful here, whether or not b is positive or negative, this part here, this thing squared will always end up being positive. And then here's the place where I see most of the mistakes happen. I've got minus 4 times 1 times minus 6. I have to be extra special careful about the sign here. It's a negative times a positive times a negative, so overall it's going to be positive. So minus 4 times 1 is minus 4 times minus 6 is positive 24. All over 2. This simplifies further. I get 5 plus or minus the square root of 25 plus 24 is 49, all over 2. And then if 49 wasn't a nice square number, I would stop here. So like if this was 5 plus or minus the square root of 17 all over 2, that would be my final answer. I couldn't simplify it any further. But here, since 49 is a square number, I can simplify further and say it's 5 plus or minus 7 all over 2. And then I do want to write these as two different answers. I'm going to get 5 plus 7 over 2. 5 plus 7 is 12. 12 over 2 is 6. Or 12 divided by 2 is 6. And then I also get 5 minus 7 over 2, which is negative 2 over 2, which is negative 1. So we see that whether we do it using the quadratic formula or whether we do it by factoring, we still get the same answers of positive 6 and negative 1. And that's always true. Whenever you're solving a quadratic equation, the method you use to solve it doesn't matter in that it won't change your answers. Let's look at another example that we could do either way. Yeah, let's see. Gotta keep my notes in order here. So whoever left comes back. So there we are. Or maybe. So let's look at this next example. So I want to solve this equation. I want to solve 12x squared plus 6 equal to 17x, which I'm going to, of course, rewrite as something equal to 0, right? That's always going to be the first step. If it's not equal to 0 and it's quadratic, make it equal to 0. Okay, so now we have choices. We always have choices. It's just that sometimes one of the choices is not really a good choice. Here, we could either try to factor using the method we talked about yesterday, or we could use the quadratic formula. The quadratic formula is always going to work. It's just going to be messy sometimes. Whereas factoring doesn't always work. So we could try to factor. We'll try to factor one last time. So let's see if I was, so this one, it looks like it's going to be kind of a pain to factor because my a times c is 12 times 6, which is 72. And there's a lot of ways to multiply the 72. So I'm trying to multiply to 72. And I'm also trying to add up to negative 17. You might know how to do this, but if you're doing it the James way, where you start with like the biggest factors and you work your way towards the smallest ones, it's going to take a minute, right? It could be, so first of all, we know they both have to be negative numbers because they're adding up to something negative and they're multiplying something positive. So I'm not going to write positive things, I'm going to write negative things. So I could do negative 72 and negative 1. That's clearly not right. That adds up to negative 73. Or I could do negative 36 and negative 2. Still 2 negative, it adds up to negative 38. I keep going. Negative 24, negative 3. Nope, still 2 negative. Right? Anything that's bigger than negative 17 or more negative is not going to be right. I could do negative 18 and negative 4. Nope, still not going to be where -12 and -6. Almost, but not quite there. And the last possible option, -9 times -8. That multiplies to 72 and does add up to -17. But the point of this really is to show you that while you might be able to factor something, sometimes you have to check a lot of things to be able to tell if you actually can. Whereas the quadratic formula is always, I mean, there might be some simplifying you have to do, but it's always just throw it all into the equation and there's your answer, and then you have to simplify it. Here, if we were going to continue factoring this one, we would rewrite our polynomial, our quadratic, as 12x squared minus 8x minus 9x plus 6 equal to 0. And then we do the whole factoring by grouping thing. So we say, okay, from this first factor, I can factor out a 4x. I'm left with a 3x minus 2. And from this factor, I can factor out a 3, but I'm going to choose minus 3 because I know I'm going to be left with a positive 3x. I'm going to factor out a minus 3 and be left with 3x minus 2. Then I factor out the 3x minus 2, and I'm left with 3x minus 2 times 4x minus 3. So from here, I can see that 3x minus 2 equals 0. So 3x equals 2. So x equals 2/3. By the way, I should mention, when you're factoring, I'm perfectly fine with you not showing all of this work when you, like, if you get to 3x minus 2 equals 0, it's perfectly fine just to jump straight to x equals positive 2/3. Because when I see this, I'm thinking of like putting the 2 on the other side and then dividing by 3. Same deal here. You could show all this work where you can say, okay, I know 4x minus 3 equals 0. I'm going to add 3 and say 4x equals positive 3. And then x equals 3/4. You're welcome just to jump straight to those final 2 answers there. Or we could not factor it at all. Be smart and move my equation up. We can instead say, I would rather do the quadratic formula. Now, some equations are just kind of ugly and are going to have challenging bits and pieces no matter what you do. So here, A would be 12, B would be -17, and C would be 6. You don't have to write those down, but you certainly can if it helps you remember what's what. So then, just drop everything into the formula. I think it's probably, so I usually don't write -17. I usually do that simplification right away and say, okay, -17 is positive 17. So I'm going to get positive 17 plus or minus the square root of -17 squared minus 4 times 12 times 6 all over 2 times 12. And I will admit freely, these numbers are a little big for what we usually are able to do in our heads. One year I had an office that was in room 289, and I definitely noticed that 289 is 17 squared, right? That's just something that's like, oh, 17 squared, that's my office number. So 17 squared is 289. It comes up sometimes. It also does come up as a Pythagorean triple, right? 289, or sorry, right? Right. There was definitely a homework problem or a test problem where the triangle was a 15, 8, 17 triangle, because 15 squared plus 8 squared equals 17 squared, which is 289. So 289. And then here's how I would do 4 times 12 times 6. 12 times 6 is 72. 72 times 4. Whenever I have to multiply by 4 and it seems hard, I just multiply by 2 twice. 72 times 2 is 144. 144 times 2 is 288. Well, that turned out nice. I've got 17 plus or minus the square root of 1. And the square root of 1 is just 1 all over 24. So I've got 17. So again, when you get ones like this where the square root goes away, right, where you square a nice square number and you just get a nice integer value there, then you should write your answers as simplified as possible. I mean, you should actually add and subtract the 1. So you get 17 plus 1 over 24, which is 18 over 24, which reduces to 3/4, or 17 minus 1 over 24, which is 16 over 24, which reduces to 2/3. So in both of these cases so far, our answers have been rational, right? You can write them as a fraction or as just a nice integer number. Right, same answers we got there. Not all of our answers are going to be nice rational numbers. So sometimes we're going to get square roots that don't just go away. So let's look at another example. It's all examples today. Yeah, we'll leave that up for another minute. So let's look at some smaller numbers. Let's say that we wanted to solve the equation x squared equal to 4x plus 3. And so of course, first, I'm going to rewrite it. X squared minus 4x minus 3 equal to 0. I should point out, you could, if you really, really wanted to, write it as 0 equal to negative x squared plus 4x plus 3. And you could do it that way and say that A was -1, B was +4, and C was +3. But if you have the choice, and you almost always do have the choice, you should be choosing to make the coefficient of x squared positive, right? That is always the better, nicer, easier choice. So I would refrain from doing it this way. Sometimes there's a good reason to maybe do it that way. I can't really think of one, but there might be a good reason to. But if there's no reason to, do it. And what I'll say about this one is this one almost always kind of fools me at first into thinking, well, maybe we can factor that, right? Like we could multiply to this and maybe add to that. We cannot, right? Because to multiply to -3, it's either -3 times 1 or 3 times -1. In either case, those don't add up to 4, right? -3 plus 1 is -2, and 3 plus -1 is +2, which is not -4. So this one doesn't factor. There's no way to multiply to A times C, which is -3, and add it to B, which is -4. So we're stuck. So that's really kind of the point I want to make with this one first is you can't always factor a quadratic, right? Sometimes you have to do something else. And although there are other options, the something else that you really should default to is just using the quadratic equation. I will mention there is something called completing the square, which technically always does work as well, but it's such a computational pain. I would encourage you to not do that unless someone specifically says complete the square. Yes, we do complete the square for other reasons at other times, but that's kind of a different process. So yeah, completing the square is not all bad. It's just here is not what you want to do. So here I'm going to solve this by using the quadratic formula. So A equals 1, B equals -4, and C equals -3. And then we just put it. Now remember, we're solving this, so our solution is x equal to -4 plus or minus the square root of -4 squared minus 4 times 1 times -3 all over 2 times 1. And then we definitely should simplify this. Here's a good thing to be aware of. If B is even, it's always going to simplify kind of a lot. If b is odd, it usually doesn't, but it still can. But especially if you see that, oh, my middle term is an even coefficient here, there's always going to be a decent amount of simplifying you have to do. So this is going to be positive 4 plus or minus the square root of negative 4 squared is 16. And negative 4 times 1 times negative 3 is positive 12. All over 2 times 1. So this is equal to 4 plus or minus the square root of 28 over 2. All right, I'm going to make a mistake right now. Don't write this down because I'm going to erase it. Here's a mistake. So here's the mistake I made. So I'm going to do this, right? It's actually not equal to that. So the mistake I made was I divided 4 by 2, or I canceled the 2, right? 4 divided by 2 is 2. But the thing here is that this entire expression is this plus or minus this all divided by 2. So 4 is divided by 2, and the square root of 28 is also divided by 2. So you have a couple choices about how to proceed. You can either, one way is just to actually write it as 2 fractions. You can write it as 4 over 2 plus or minus the square root of 28 over 2. 4 divided by 2 is 2. And then the square root of 28 actually does simplify further. 28 is a multiple of 4. I can write this as the square root of 4 times 7. And then the square root of 4 is equal to 2. So this is 2 plus or minus 2 root 7 all over 2. And then this 2 divided by this 2 can cancel. And you're left with 2 plus or minus root 7. And I would encourage you to leave your answer like that using the plus or minus notation. But you can also alternatively write your answer as 2 plus root 7 and 2 minus root 7. Because there technically are, right, there are 2 answers here. 2 plus root 7 and 2 minus root 7. But we can write them as 2 numbers like this, 2 plus or minus root 7. Are there questions about this? It's very warm in my office today. Something. Let's see where we're at here. Some more examples. Let's look at this one. X squared plus 6x plus 3 equals 0. Really, most of these examples, a lot of them, are just kind of showing you most of the process of simplification, right? You throwing this into the quadratic equation is not too terrible, but the simplifying process, which we really want, can be kind of terrible. So my solutions, so I guess I could write, A is 1, B is 6, C is 3. So my solution to the quadratic equation is going to be negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 3 all over 2 times 1. And now we're going to make it simpler. It's going to be negative 6 plus or minus the square root of 6 squared is 36. 4 times 1 times minus 4 times 1 times 3 is minus 12 all over 2. And although you can break this up into 2 pieces like we did for the previous one, I will tell you that here I prefer to do something slightly different, which is still the same word. Here is something though that is always going to be true. If b is even, right, if this number is even here, you're always going to be able to pull out at least a 2 from inside the square root. It's always going to be true. And actually the reason is because if b is even, then for sure the insides here are going to be a multiple of 4. An even number squared is a multiple of 4. And 4 times this other stuff is a multiple of 4. When you subtract or add multiples of 4, you still get a multiple of 4. So definitely, if this is even, then the insides here are going to be a multiple of 4. Meaning square root of 4 comes out as 2. So meaning you're going to have to simplify if you have an even middle number. All right, so here's what we get. We get negative 6 plus or minus the square root of 24 all over 2. And before I do any dividing, I'm going to say, well, what's the biggest square factor of 24? It's going to be 4. So negative 6 plus or minus the square root of 4 times 6 all over 2. I'm okay with you skipping this step, right? I don't need you to write 24 as 4 times 6. What I do need you to write is that the square root of 24 ends up being 2 times the square root of 6. Because the square root of 4 is 2, and the square root of 6 is the square root of 6. And then I can divide each of those by 2. So negative 6 divided by 2 is going to give me a negative 3. 2 root 6 divided by 2 is going to give me just root 6. So you can do that, or you can break it up and say it's negative 6 over 2 plus or minus 2 root 6 over 2. That's going to give me negative 3, and then 2 over 2 is just 1, so 1 root 6. One thing I want to make sure everybody knows, when you have things multiplied together and you're dividing that, you only divide one of the things. So like if I had something like, 6 times 8 times 9 divided by 2, I can only cancel a 2 from one of those factors. So I could say this is equal to like 3 times 8 times 9. That would be one way I can simplify that. But you can't cancel a 2 from each of the even things. Yeah. Let's look at a similar but slightly different problem. And if anyone is interested in hearing me talk about how to complete the square to solve these, I don't think that's something that's super important, but if you want to stick around for office hours afterwards, I'm happy to show you in office hours how you can solve any of these using completing the square. Which sometimes has its what's the word I'm looking for? Sometimes has its benefits. There are definitely some upsides to completing the square. Sometimes the arithmetic is a little bit easier, but not usually. So again, so I should point out, for each of these problems that we're solving, in the back of my mind, I'm at least thinking, could I factor that? No, I couldn't, right? There's no way to multiply the negative 3 and add it to positive 6. But usually when you're solving these quadratic equations, you really want to think, okay, can I factor it first? If it doesn't look like I can factor, or it doesn't look like it's easy to factor, then we're going to jump straight to the quadratic formula. That's usually the method I use to solve any kind of equation like this. So here, we're going to get our solutions are x equal to negative b plus or minus the square root of b, which I'm not writing a b there, that's a 6, of b squared, which is 6 squared, minus 4 times 1 times negative 3. This is almost the same problem, except that we have a negative here instead of a positive before, right? In the previous problem, c was positive 3, and this problem c is negative 3. That's going to change things a bit. This is going to be negative 6 plus or minus the square root of, that's going to be 36. But now it's going to be minus 4 times 1 times minus 3, which is going to be positive 12 all over 2. And then we're going to get negative 6 plus or minus the square root of 36 plus 12 is 48. Now, it's not always easy to see what the biggest square factor is. You don't actually have to find the biggest square factor at first. You can start with any square factor. And I can definitely tell that 48 is a multiple of 4. So I can rewrite this as negative 6 plus or minus the square root of 4 times 12 all over 2. Square root of 4 is 2. This is negative 6 plus or minus 2 root 12 all over 2. And then I can divide each of those by 2. So negative 6 divided by 2 is negative 3. And 2 root 12 divided by 2 is root 12. Now, I'm not quite done because root 12 has another square factor inside. 12 has another factor of 4. So I should rewrite this as negative 3 plus or minus the square root of 4 times 3, which is negative 3 plus or minus 2 root 3. And I will also say, we could have skipped some of this if in the beginning we had recognized that 48 factors as 16 times 3. Right? Then we could have been like, oh, the square root of 48 is just the square root of 16 times 3, which is 4 root 3. Okay, so if we had 4 root 3 there, then we would have immediately gotten to 2 root 3. But either way is fine, as long as you can get there. Much time? Okay, yeah, I got enough time for sure. So a lot of these can be simplified. I will say again, and I really just noticed this today. If your middle term, right, if your b value is even, you can always expect to do some simplifying. So you should just get it, drilled into your head. If your b value is even, you have to do some simplifying. But you're going to have a factor of 4, it's going to come out as a 2. But let's look at some other examples. Let's look at something like 2x squared plus x equal to 5. And of course, the first thing we do is write it as 2x squared plus x minus 5 equal to 0. I think all my blue pens are dying. You grab a fresh green pen. So here is 2, b is 1, and c is negative 5. And I mean, right, it kind of gets old, right? It's just doing the same thing over and over and over again. But there's a couple things I still want you to see. So we'll do this example, and then the next thing has, so let's say, and so I will point out, right, this one you might look at and be like, well, I might be able to factor that. Right? Maybe there's a way to multiply to negative 10 and add it to positive 1. But I just don't want to bother, right? It's more work than I think you want to do, than I want to do. So I would rather just jump straight to the quadratic equation. Negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 5. I also think it's perfect, over 2 times 2. As I said, I also think it's perfectly fine. You don't need to write 1 squared here. You can just write out whatever it is right here. You can just write 1. Or in the previous problem, right, when we were doing this, you don't have to write 6 squared. You can just write 36, right? You know how to square most of these smallish numbers. So you can do some simplifying right away if you want to. So here we get negative 1 plus or minus the square root of, this is 1, minus 4 times 2 is minus 8, times minus 5 is plus 40, all over 4. And then this simplifies as negative 1 plus or minus the square root of 41, all over 4. And that's really it. We can't do anything else. Some people like to break this up into 2 fractions. I think if you can't simplify further, you should just leave it like that. Some people, not me, I don't think you should have to do this, want to write it as negative 1/4 plus or minus the square root of 41/4. Either way is acceptable, but I would stick with that because it feels easier. Okay, more examples. Examples. Again, stop me if you have a question. It's Alexa, I am sorry if you have been waiting for a while. I did not see you come in. I apologize if I missed you. Hopefully you weren't waiting too long. We're talking about the quadratic formula. Yeah, sorry about that. I don't know if I just have to pay attention. I'm trying to think, like, is there a way someone could tell me? If you know your friend is trying to get into class and they're not in the class, you can write something in the chat like, hey, James, Alexa told me she's waiting. Let her in. But of course, I guess if I was looking at the chat, I would also be looking at the other things. So sorry. I want to solve this. And of course, we're going to do the thing where, right? So always, 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 we are jumping straight to setting it equal to 0. So I've got 9x squared minus 12x plus 4 equal to 0. And maybe I could factor this. I don't know. Instead, I'm not going to bother, right? So factoring this would be maybe especially painful because 9 times 4 is 36. So you're looking for ways to multiply the 36 and add it to negative 12. And while that might not be too hard to figure out, I think it's easier to use the quadratic formula. So x is going to equal, I should say, right? So there's my a, there's my b, there's my c. So x is going to equal negative b plus or minus the square root of b squared. So negative 12 squared is going to be positive 144 minus 4 times a, which is 9, times c, which is 4, all over 2 times 9. All right, and now we're going to simplify. We're going to get 12 plus or minus the square root of 144. 144 minus 4 times 9 times 4 is 144. There's a couple ways, I mean, you can multiply it out. You could also think of it as this is 4 times 9 is 3 times 3, it's 4. 4 times 3 times 3 times 4 is really 12 times 12, which is 144. So that's an easy way to see that 4 times 9 times 4 is 144. There's a couple other ways you can do it. I mean, you could really just multiply, right? 4 times 9 is 36, 36 times 4 is 144, or whatever. But the point here is that this is going to be 0. So you get 12 plus or minus 0, which is over 18. But that's just 12 over 18, which reduces to 2/3. So in this case, where the stuff inside the square root is equal to 0, we only get one solution. And it's rational. It's a fraction. Here's something else I want you to know, because I think this is actually a really important point. If you use the quadratic formula and you get rational answers, meaning fractions, meaning not square roots, that means 1, you could have factored it, and 2, you can actually figure out how to factor it. So if I know that 2/3 is going to be one of my one of my solutions, actually my only solution, I know that I could have factored this, that. Into factors where 2/3 is the answer, which is looking like 3x minus 2, right? If 2/3 is my answer, 3 times 2/3 is 3. 3 times 2/3 is 2, and then 2 minus 2 is 0. So that's what I'm doing. I'm multiplying this by 3 to get 2, and then subtracting 2 to see that it's 0. And then I actually get that twice. So when you get only one answer, it's what we call a repeated answer, or a repeated root, or a repeated solution. Because it's the solution you would get from either of the 2 factors. And of course, you could write this, if you were factoring it, as 3x minus 2 quantity squared. But the bigger picture thing that I want you to see from this example and from the next example is that if you factor something, sorry, back up. If you use the quadratic formula and you get answers that are fractions or rational numbers, right, that don't have roots or irrational numbers in them, you actually, it tells you how you could have factored it. Let me show you another example. Let's see. 4x squared minus x minus 3 equals 0. This one, so personally, if I have a coefficient here that's not 1, I usually am not going to try to factor it. I'm just going to be like, that's more work than I want to do. I'm not going to factor. I'm going to use the quadratic formula. So A is 4, B is -1, C is -3. So my solution here is going to be x equal to negative b, so sorry, -1, which is +1, plus or minus the square root of b squared, which is -1 squared, which is just 1, minus 4 times a times c, all over 2 times a. So I end up getting 1 plus or minus the square root of 1 minus 4 times 4 is -16 times -3 is +48. Or it's probably easier, at least I think it's easier to do -4 times -12 is +48. All over 8. 1 plus 48 is 49, square root of 49 is 7. So this is 1 plus or minus 7 all over 8. So I end up getting 1 plus 7 over 8, which is just 1, or 1 minus 7 over 8, which is -6 over 8, which is -3/4. And so here's what I know. I know my answers are rational, which means I could have factored if I wanted to. So here's what I want to point out about the factoring. So this thing factors. So here's the quick but not quite right way to factor it. I need 1 and I need -3/4 to be solutions. So I can say, all right, I'm going to have an x plus 3/4 and an x minus 1. This is definitely, if you multiply this out, this would be a quadratic, and it would have -3/4 and +1 solutions. But here's the thing that's kind of important. This polynomial isn't exactly the same as this, or this quadratic isn't really the same as this. If you multiply this one out, you're going to get 1x squared. If you multiply this one out, you've got a 4x squared. And so to adjust for that, you multiply by 4. And then you distribute the 4 to the first factor here, the one that has the fraction in it, so that you've got 4x plus 3 times x minus 1. And that's how you can see how this will factor. You could also just say, I know that if I want -3/4 to be a factor, then I want 4x plus 3. Or sorry, if I want -3/4 to be a solution, I want 4x plus 3 to be one of the factors. But you can also kind of do it this longer way if you wanted to. Yeah. Let's see. Yeah. I was going to say that, but I had one more example. What time is it? Okay. So the homework that's due tomorrow shouldn't have any equations that have imaginary or complex numbers. There were a couple mistakes, someone caught them, but if there were, I would want you to say there were no solutions. So for example, if someone said, solve this, Well, I would use the quadratic formula because I don't know how to multiply to 5 and add up to 2. So I would start using it. I would get x equal to -2 plus or minus the square root of 2 squared minus 4 times 1 times 5 all over 2 times 1. This is going to give me -2 plus or minus the square root of 4 minus 20 all over 2. 4 minus 20 is clearly negative. It's -16. And at this point, once we realize we have a negative inside the square root, that's when we get to say, oh, there are no real solutions. There are what we call complex or imaginary solutions, but we're not going to address that right now. One thing I will say about this is that when the inside, so basically the idea here is that if the inside of the square root is negative, you're not going to have any real solutions because they're going to be imaginary. If the inside is positive, then you're going to have real solutions. And if the inside happens to be exactly 0, like it was in that problem a couple problems ago, you get exactly one solution repeated. This stuff inside here, this b squared minus 4ac, is called the discriminant. Sometimes people use a capital D. I don't really, but some people do. And the only reason I'm mentioning is because you will often hear teachers talk about, like, if the discriminant's positive, then we have real solutions. Or if the discriminant's negative, then we have complex solutions. And I will say, especially for those of you that plan on taking the 17 series, knowing when the discriminant's positive or when the discriminant's negative actually becomes a big deal in 17C. So if you're looking at the 17 series, the quadratic formula actually is, I'm helping students currently with 17C. We're talking a lot about, like, oh, is the inside here positive or negative? All right, that means we have a spiral instead of having a other thing. So it actually is something that's kind of important to know.